Welcome to this video about one of the most exciting aspects of AI development, fine-tuning a large language model. If you've ever wondered how you can adapt a model to better suit your specific needs, this is the video for you. My name is Sam Batali, and in this video, I'll walk you through a step-by-step process of how to fine-tune a model so you can follow along and apply the same techniques to your own projects. And stick around until the end because I will be providing a downloadable template to help you fine-tune your own models. So what exactly is fine-tuning? In simple terms, is the process of taking a pre-trained model and refining it to perform better in a specialized task. Imagine you have a model trained to understand general language, but you want it to be an expert in analyzing financial reports or generating creative writing prompts. Fine-tuning lets you do just that. Why might you want to fine-tune a model? Well, it's all about customization. The base model is trained on a broad data set, but your specific use case might require the model to have a deeper understanding on a niche area. Fine-tuning allows you to adapt the model to perform exceptionally well in your specific domain, which can lead to better accuracy and more relevant output. For example, you can fine-tune a model to become an expert on your business, enabling it to handle customer inquiries and generate on-brand emails and etc. etc. There are very many use cases for a fine-tuned model, but two of my favorites are creating chatbots that you can embed on your website and they can provide 24-hour customer support. And secondly, creating AI agents, which are autonomous programs that can reason and take actions on their own. And I believe AI agents are the future of AI. I will be releasing videos about these topics very soon, so stay tuned by subscribing to this channel. Our demo project will involve fine-tuning an OpenAI large language model to moderate comments on children's videos. This is a crucial task given how important it is to maintain a safe environment for our kids online. We'll be training the model to label each comment as either allowed or disallowed based on specific criteria. Now let's start by importing all the modules that we will use in this project. We will be using the OpenAI module to interact with OpenAI APIs. We'll be using pandas and JSON to prepare our training data, and we'll be using matplotlib to plot some graphs and visualize the performance of our model after fine-tuning. Now, for us to be able to fine-tune an OpenAI model, we need an API key, and you can get an API key by signing up for an account at platform.openai.com. And after you get your OpenAI API key, you can now initialize the OpenAI client using this snippet of code. The next step is now preparing our training data. I have collected a bunch of user comments that I put together in a CSV file. The CSV file has 4 columns. The first column contains the user ID, the second column contains the comment, and the third column contains the date that the comment was posted, and the last column contains the label that I've assigned to the comment. As you can see here, the first example says this video is so funny and the label is allow, and the third one says this game is stupid, the creator is a loser, and the label is disallow. We only need the user comment and the label in this CSV file to fine-tune our model. But for us to use this training data to fine-tune an OpenAI model, they need to be converted to a format that OpenAI accepts. And the format that OpenAI accepts when fine-tuning their models is in this JSON format, which contains a list of message objects. And the first object has a role of system, and the content for this object is going to be a system prompt that we are going to create, and the prompt will guide the model during the fine-tuning process. And the second message object has a role of user, and here we are going to provide the user comment that we are going to extract from the CSV file. And the third object has a role of assistant, and the content for this is going to be the label that we've assigned to the comment. Now let's start by creating our system prompt. Creating a very good system prompt is very important. This is what will guide the model during the learning process. Here's a very good example that I'm going to use. It says, given a user comment on children videos, check if the comment is appropriate for children and determine if the comment should be allowed or disallowed for children to view. Return a single word in the following format. Allow if the comment is safe for children, disallow if the comment is not safe for children. This prompt is concise and straight to the point. It clearly communicates our intent and instructs the model on how it should return responses. Now let's actually convert our training data to the correct format. We are looping through each row from the training data and we are converting it to the required JSON format. And we will also be writing all of these JSON objects in a JSON file called trainingdata.json. And as you can see, I've expanded the first entry so you can clearly see how the data is organized. And after putting all our training data into this JSON file, we need to upload this file to OpenAI so that we can be able to use it for fine-tuning. And we upload the file by calling openai.files.create, and we provide the file, and you need to also provide a purpose, and the purpose has to be fine-tuned to indicate that this file is going to be used for fine-tuning. This function will return a file object with an ID, and we need to keep record of this ID as we will be using it when creating our fine-tuning job. Now we're done with our data preparation step. We are ready to start fine-tuning, and we can initiate the fine-tuning process by calling this function openai.finetuning.jobs.create. And like I said before, you need to provide the file ID and you need to provide the base model that we are going to be fine-tuning. And in our case, I am going to be fine-tuning GPT 3.5 Turbo. You also have the option of providing extra hyperparameters such as the number of epochs, the batch size, and the learning rate. And that's it. We've initiated our fine-tuning job, and this function also returns a fine-tuning job object with an ID. We will be using this ID to access our fine-tune model. Now we just have to wait until the job is done, and I have this snippet of code here that is going to keep checking if our job has finished fine-tuning or if it failed for any other reason. It will print job succeeded at the end when everything is done. Now, after the fine-tuning process is finished, we need to analyze our model and see how it learned. And the two metrics that people use to analyze a model when you're fine-tuning or when you're building an AI model from scratch is the training loss and the token accuracy. And in simple terms, the train loss tells you how close the model's predictions are to the actual values, while the train accuracy tells you how often the model is correct. And the good thing is OpenAI records the train loss and the train accuracy of our model in every step of the training process. That means after every epoch and at the end of each batch. And you can grab this data by calling openai.finetuning.jobs.list events. Provide the fine-tuning job ID. I'm extracting the step, the train loss, and the train mean accuracy from the events that I grabbed from OpenAI, and I'm putting in their individual lists using this snippet of code. And now we are ready to plot this data and see how our fine-tuning process went. And this is the graph that I got from plotting the data, and as you can see, it shows that our model has 100% accuracy and 0% train loss from the beginning to the end. And this is because the fine-tuning job that we are training this model for is so simple that we didn't even need to fine-tune GPT 3.5 for it. The model is already smart that it can output the correct label based on our prompt without it needing to be fine-tuned. But I have another graph here from a previous fine-tuning job that I did, and as you can see, it shows the train loss is really high in the beginning, and as the model keeps learning from the data, the train loss become smaller and smaller and smaller. And this is what we want to see when we are fine-tuning a model. What if after fine-tuning, your model did not show a decreasing training loss and increasing token accuracy? For example, if it bounces up and down from the beginning to the end, that means you need to go back and re-examine your training data. Sometimes you need to add more training data if you don't have enough. And sometimes if your data is skewed into one direction, you probably need to make sure it's balanced. Sometimes it could be as easy as grammatical errors in your data, so you need to filter those out and fix them, and then you can retrain the model again, and hopefully you can see an improvement. Now, after the fine-tuning job is done, we've analyzed our model and it's showing good performance. We are now ready to use our model. We can do further testing on the model and deploy it to production. To deploy your model, you need to first get your fine-tune model ID, and you get that by calling your fine-tune job.fine-tune model, and it will return for you an ID that you can use to access your model from OpenAI. And I've created a simple function here that will be making a request to the AI model that we've just fine-tuned and getting responses from it. The function accepts the comment and the model as arguments, and it will create a chart completion by calling openai.chart.completion.create, passing in the model and our messages. And compared to when we were fine-tuning, our message now contains two objects, one with the role of system, and the content is going to be the system prompt that we created earlier, and the second object has a role of user, and the content is going to be the user comment that we pass into the function. And this will return for us a response, and a response will be the label that the fine-tuned model have assigned to the comment that we pass in. As you can see in this example, I have our train model ID and a user comment that says, "I love this video." When I call that function and pass in the comment and the train model name, it returns allow. You can also compare your model to other models to see how they both performed. In a more specialized task, the fine-tuned model will outperform any of the generic models like GPT-4 and GPT-3.5. And that's it. We have successfully gone through a step-by-step process of how to fine-tune an OpenAI model. We started by importing all the Python modules that we use in the project. After that, we prepared our training data and made sure the data is transformed to a format that OpenAI accepts. And after preparing our training data, we initiated the fine-tuning process. And when our model has finished fine-tuning, we analyze it to make sure it learned properly from the training data. And that gives us a fine-tuning model ready to deploy in production. If you are looking to fine-tune your own AI model, you can follow the same steps shown in this video. In addition to that, you can download the same template that I use in my own projects attached in the description of this video. I hope you found this video helpful. If you did, like, subscribe, and hit the bell icon to keep updated with more AI content. Thank you so much, and see you in the next video.